everyone, and welcome to lesson 7.2. Today we are going to talk about similarity transformations. A similarity transformation is a composition of transformations, and it is made up of a rigid motion and a dilation. So our reflections, rotations, and translations from previous topics and our dilations from our previous lessons. Now, these figures are not going to be congruent. What they're going to be called is similar, and the symbol for that is just the tilde without the equal sign. So in our picture here, we are given triangle ABC, and that's going to be a similar figure. Notice the use of this similar symbol, not a congruent symbol, to either A prime, B prime, C prime, or A double prime, B double prime, C double prime, because they are the same shape, but a different size. So again, we keep the angles congruent, but the sides are only proportional. So in this particular photo, in this similarity transformation, we had a reduction from A, B, C to A prime, B prime, C prime, and then we did a reflection in order to reflect from the primes to the double primes. So we noticed that this changed again the size, and then we had that rigid motion. Down here then, we also have a fact that we are going to want to know, and it's the idea that all of our circles are going to be similar to each other. So in our example here, circle P and circle Q are going to be similar to each other because we can transform those radii by a dilation to be the same size and then translate so that the centers are on top of each other to prove they are similar indeed. Now, when actually performing our compositions, very similar to last semester, we are going to write down both an intermediate and a final image each time. So the first one wants us to start by performing a translation to XYZ, so that becomes our primes. So we need to move 2 units to the left and then down 4 units to be able to graph this image. So we take all of our points, we go left 2 and down 4, so we end up at 1, 1 for x prime. Y goes left 2 and down 4, so y prime is at negative 3, 0, and then left 2 and down 4, we end up at 5, negative 3 for z prime. Again, we graph, and as well as plotting our points 1, 1, negative 3, 0, and then 5, negative 3. From there, we are going to take our translated image and make that into another translation of transformation of a dilation of 2. So to get the double primes, we are going to take the primes here, and we are going to dilate them by our scale factor of 2. So essentially, we are multiplying by 2 each of these values. Remember, 0 divided by 2, or times 2 was still 0. So we have 2, 2 for the location of x double prime, negative 6, 0 for y double prime, and then 10, negative 6 for z double prime. And that would be our graph then of our final image. So you would want to make sure you graph both the intermediate and the final. Now on our next one, we want to start off this time with a reflection over the line x equals 1. So reminder, x equals 1 is a vertical line through the number 1, and each of these points, depending on how far they were from the original. So for instance, this x was 2 units away from the right. We are now 2 units from the left. Y was 2 units from the right. It is now also going to be 2 units from the left. So y prime is going to go over on the other side here. and then Z was 1, 2, 3, 4, 5, 6 to the left. We need to go 1, 2, 3, 4, 5, 6 to the right. Or excuse me, was to the right, it now is to the left. There is Z prime. So here, again, is our intermediate image of X prime, Y prime, Z prime. X is at negative 1, 5. Y is at 3, 4. Z is at negative 5, 1. Now our second transformation is a dilation of 1/2. So again, we're going to take those intermediate image points and we are going to this time multiply each of those by 1/2 so that we end up getting each of these values. So 3/2, 2, negative 5/2, and then 1/2. Now, if you put the decimal equivalents as well, side note, so negative 0.5, 2.5, that also works, 1.5, or again, if you call this negative 2.5, 0.5, know that those are equivalent, whether they are fractions or decimals. Now, as we write these, then we want to go to the negative 1/2, 2.5. Here is X double prime. Y double prime is at 1.5, 2. And Z double prime, negative 2.5, 1/2. So this little guy right here. So again, we reduced it to have this smaller image. Our next example wants you then to come up with a dilation around the origin. So find A prime, B prime, and C prime. And then finally, you will also find and graph your double primes. You will then translate them T5, 6. All right, the last type of similarity transformations we are going to talk about today involve our rotations. Remember, we have our rotation rules from last semester to help us with these as well. So on our first one, we want to start with a dilation of 3 for our triangle K8T. So we are going to take each of these points and all 3 points get multiplied by a 3. So we get our new locations of negative 3, 0 for K prime, 6, negative 3 for A prime, and then T prime is 3, 6. And then from there, what we are doing for our final image is we are going to rotate it 270 degrees. So our 270 degree rotation requires us to take our points, flip your X and your Y value, negate the Y. So as we look for our double primes then, this time we're going to flip X and Y. Now this negative 3 is going to become a positive because again, we're changing the Y's. Flip our order. The 6 then becomes negative, and then flip our order. The 3 becomes negative. So our final image points, we have K double prime, A double prime, and then T double prime after our rotation. All right, one final example for you to try. We're going to start with a rotation 180 degrees. Remember our rule from up above for 180 degree rotation. And then after you find Q prime, R prime, S prime, using that rotation rule, you are going to dilate by half to find your final image. Don't forget to graph. Thanks everyone for watching. We'll work more with these in class.